Hello and welcome, and this is going to be the first lecture video for college algebra. So if you're watching this is going to begin Chapter 1, Section 1 with the equations and inequalities, and this video will cover Section 1. This PowerPoint presentation goes through all of Chapter 1, but I'm going to do this up in separate videos. So the first chapter is going to be, or the first lecture rather, is going to be Chapter 1, Section 1. So here's what we're going to do. This is the chapter outline. So we're going to cover this today, and then the next video will cover section 1.2, and so on and so forth. So we're going to start with linear equations, formulas, and problem solving. Okay, so here's what our objective is today. We're going to cover these things: A, B, C, and D. So the first thing I'm going to start with is some properties. So there's the additive property, as you can see here, and it says if A, B, and C represent algebraic expressions, meaning that A is of the form of like some algebra problem, like an algebra expression. So when we talk about an algebraic expression, we're talking about things that are like x times y divided by w. That's an algebraic expression. Why? Because it involves variables. Okay, so an algebraic expression is anything that includes some variable, at least one variable, is considered an algebraic expression. So what this is saying is that the additive property is applied to the sum and differences of algebraic expressions. So if A, B, and C are algebraic expressions, and A equals B, then A plus C is equal to B plus C. And A minus C is equal to B minus C. Okay? And then the multiplicative property of equality says that, again, if A, B, and C are algebraic expressions and A equals B, then AC times BC is also equal. And AC divided by, A divided by C is equal to B divided by C, as long as C is not equal to 0, of course. Oh. So now, here are the guidelines. So here's the guides to solving equations in one variable. So it says, 1, eliminate parentheses. So think about your order of operations. So the first thing we're going to do is we want to eliminate parentheses using the distributive property, then combine any like terms, then use the additive property of equality to write the equation with all variables of the term on one side, all constants on the other, and then simplify each side. So think about these as kind of like the order in which you want to do things. First thing, you want to eliminate any parentheses, like by using the distributive property. Then combine any like terms. Then once you do that, then you're going to use the additive property of equality to get all of the variables on one side of the equal sign and all of the constants on the other side. Then you're going to use the multiplicative property of equality to obtain an equation of the form x equals a constant. Okay, so basically this is the goal. You want to get everything in the form of x on one side equals to just a constant on the other side, or some numbers on the other side. And then for applications, answer in complete sentences. This is an important one for word problems, application type problems. You're always going to want to make sure that your answers are in complete sentences, and then you also want to make sure that you use the correct units in your answer. So if you say x is equal to 2, but you don't tell me what the units are, I don't know if you're talking about $2, 2 seconds, 2 grams, I don't know. So you got to make sure you, whenever you answer a word problem, it's got to have a complete sentence and the units. And I just don't take offense to this, but I tell my kids all the time at home when they're doing word problems, they have to do the same thing. So guess what? This also applies to college. Okay, so this doesn't go away. You've been seeing this probably for a long time. Okay, So here's an example. So it says solve the linear equation using properties of equality. So the first thing we're going to do is we're going to look at this and we say, 3 times the quantity x minus 1 plus x equals negative x, or the opposite of x, plus 7. So the first thing we're going to do is we're going to get rid of those parentheses by using the distributive property. So we're going to distribute the 3 to the x and then distribute the 3 to the 1. And so we're going to get 3x minus 3 here. Okay, so that's one of the first things we're going to do. So let's do that. So notice how they do that right here. And so now, once you do that, once you did that, now what you're going to do is you're going to add like terms. Well, you got a 3x here and an x here. And so what do? You get a 4x minus 3 equals negative x plus 7. Okay, so now what's next? Well, now what we're going to do is we're going to use the additive property of equality, and we're going to move all the constants on one side and all the variables on the other. So we want to get anything with x on one side. So let's move the x's to the left. So we're going to use the additive property, basically saying that we're going to add x because we want to move the x. So remember, we're going to add. So if we want to get rid of this x, we're going to have to do the opposite of negative x. So we're going to add positive x, and whatever we do to one side of the equation, we have to do to the other side. That's one of the consequences of the additive property. Whatever we do to one side of the equation, we have to do to the other side of the equation. So if we add x to one side, we're going to add x to the other side. That will get rid of this x, and we'll have another x over here. So we'll get 4x plus x, which is 5x. And then to get rid of this 3, because we don't want the 3 here, so we're subtracting 3. So guess what we're going to do? We're going to add 3 to both sides. And so we'll get another 3 over here, and we'll get another 3 over on this side, which will cancel with this one. And so what are we going to end up with? We're going to end up with 5x equals 10, and then we're going to use the multiplicative property of equality. And so we want to get x by itself, right? So we're multiplying x by 5. So what do we have to do? Well, we have to do the opposite of multiplication, which is division. So we're going to divide both sides by 5. And when we do so, we get x equals 2, and that's the solution. Here's another one. So in this case, we're going to do the same thing. We're going to first get rid of the parentheses, and in this case, we got 2 sets of parentheses. So we're going to multiply this side. We're going to distribute the 1/4, and then over here, we're going to distribute the 1/2. So over here, we're going to get 1/4 n plus 8 divided by 4, which is 2. So we're going to get 1/4 n plus 2 minus 2, and then we're going to get 1/2 n minus 6 divided by 2, which is 3. And then we're going to add like terms. Okay, so we get this, and this 2 cancel, so we get 1/4 n equals 1/2 n minus 3. And so now what we're going to do is the additive property again for equality, and we're going to subtract 1/2 from here and subtract 1/2 from here. And then since there's no constants to move, we'll already have the constants on one side. And then all we have to do is use the multiplicative property. And so when we do that, okay, we'll get the correct answer. Now look at what they did here. Okay, so they didn't use the additive property of equality right away. They used the multiplicative property. And what they did was, since we're multiplying by a 4th here, or in other words, dividing by 4, we can multiply both sides by 4. Okay, so the 4 divided by 4 here, because this is 1/4 times 4, which gives you 1. So whatever you do to one side of the equation, you have to do to the other side. So here they're multiplying this entire side by 4. And so when you multiply through by 4, you're going to use the distributive property, and this is going to be 2, and then this is going to be a negative 4/3. Or excuse me, I'm sorry, not 4/3. You're multiplying. It's 12. So then you get n equals 2n minus 12. And then they use the um, addition property. Okay, so here they use the multiplicative property for equality first, and then they use the additive property for um, equality. So then if you basically subtract 2n from both sides, you get 0 over here, and you get negative n because you're subtracting 2n. So it gives you a negative n is equal to negative 12. And then you get n is equal to 12 because you divide by what? Negative 1. And then if, or multiply by negative 1. Divide or multiply, it doesn't matter in this case. And then n is equal to 12. So that's your solution. So n is equal to 12 in this. And then to verify, again, you always want to make sure that you verify and check your answer. So how do you verify? Well, what you do is you go back to the original problem, which is here, and you plug in 12 for n. So you plug in 12 here, and you plug in 12 here, and you want to make sure you get the same number on both sides of the equal sign. Okay, and if you do get the same number, then the solution is valid. If you end up not getting the same number, then it's not a solution. Okay, so you either made a mistake or it isn't a real solution. Okay, now here's a couple more. So these are special cases. And in this case, the reason why they're special is because unlike the last two examples, these are going to have maybe more than one solution. Okay, so if we look at A, we're going to use the distributive property. So we get 2 times x and then 2 times 4. So this is going to become 2x minus 8. And then you're going to distribute the 4 across here. And so this is going to be 12x plus 4. And so then what you're going to do is then you're going to add like terms. Okay, so here's the distribution. And then you're going to add like terms. You're going to get 12x minus 8 is equal to 12x plus 12. Okay, and then what you're going to do is you're going to use the addition property again for equality, and you're going to subtract 12x from both sides. But look what happens here. If I subtract 12x, I got 12x here and 12x over here. So if I subtract 12x from both sides, the x's go away, and I end up with negative 8 equals 12. Now, is negative 8 equal to 12? Is it? No. Will negative 8 ever be equal to 12? Will it? No. So guess what? In this case, since x drops out, it doesn't matter what value of x that you pick. You will always have this contradiction. It will always be false. Negative 8 equal to 12 is a false statement and will always be false no matter what x you choose. Why? Because x drops out. So the solution set is empty, which means that there are no solutions to this equation. So we say there are no solutions, or we represent the solution set as an empty bracket. So a set of brackets with nothing in it. Okay, so that means there's no solutions. Now what about the other one? Oops. So here we have this parentheses. So now look what happened here. Here's a common mistake students make. See, you're subtracting this entire thing. Okay, so this is a number, right? So you're subtracting this entire thing. So you cannot just drop the parentheses here without first distributing the negative sign. So you have to distribute the subtraction to the 6 and to the 10, which means that the signs change. So this becomes a subtract 6, and this becomes a plus 10. think about it as if you change this to a plus negative. And so what you're doing is you're distributing the negative sign to both of these. So this becomes a negative 6. This becomes a negative 10, but it's a minus negative 10. And so if you change it to a plus, this becomes positive. So whichever way makes sense to you, just realize that you have to distribute this subtraction sign across both of these. So what you're going to end up with is minus 6 plus 10x. And then you're going to do something similar here. You're going to distribute the 6, so this will become 18x minus 30. Okay. And so here's what you get, and there's your 18x minus 30. And so now if you add like terms, you get 18x minus 6. And you add like terms here, you're going to get a minus 6. So 18x minus 6. And look at this. The x's drop out again, right? And now this time you get negative 6 is equal to negative 6, which is true, right? That's a true statement. That will always be true. That means that it doesn't matter what x you choose, the statement will always be true, which means that everything, all values of x, is a solution. So that means that all real numbers are a solution to this equation. And so the way we represent that as an infinite set, because in this case there are an infinite number of solutions, we represent this in set notation, which means we use the curly brace with x, and then this vertical line means such that, and then after the vertical line is the rule. Okay, so which means basically what qualifies to be in this set of all x. So the way you read this is this set of all x such that what follows is true, which means that x is an element of, that's the symbol for element of, the real number. So for all real numbers, x is a solution. Okay. Okay, so now let's look at a specified variable. So now we're going to take, hey, I give you a formula like this one, and I say, okay, I want you to solve this formula for a different variable. Okay, so it says here, write P in terms of A, R, and T, and then solve for P. So given that A, and which is the accumulation amount, so this is for simple interest. This is a simple interest accumulation formula. It says given A is equal to P, which is principal, plus this is the interest. So principal plus interest. And this is the formula for interest. So that's neither here nor there, but it's incidental. But it doesn't matter what the formula is, and it doesn't matter whether you know what the formula represents. It just matters whether you can solve for a particular variable. So given this formula, can you solve this formula in terms of P equal to something? And then the answer is yes. So what you're going to do is you're going to get P on one side of the equal sign, and all the other variables have to be on the other side of the equal sign. Once you do that, you're done, and whatever is the result is your final answer. So in this case here, notice that since we're going to use this, we're going to solve for P, but P occurs here and occurs here. So we're going to use the distributive property in reverse. So we're going to factor. This is called factoring. So we're going to factor out the P. And so look, that's what they do. They factor out the P using the distributive property. And we get 1 plus RT. And now what you're going to do is, now you want to use the additive property for equality and divide by 1 plus RT on both sides, and you're done. And once you do that, this divided by this becomes 1. So you get P times 1, which is P. And then you get P is equal to A divided by the quantity 1 plus RT. And you're done. And this is the final answer. And you would leave it like that. So now, what if we have this? Now I give you another equation. And I said, okay, solve this in terms of x. So write y in terms of x, which means solve for y. So what does that mean? We want to get y on one side of the equal sign. Everything else goes on the other side. So we're going to use our properties. And the first thing we're going to do is move this 2x over here. So we're going to subtract 2x from both sides. That will get rid of 2x here and put a minus 2x over here. And then what we're going to do is, all we have to do is divide by 3. And once we divide both sides of the equation by 3, we're done. And so once we do that, we get this. Y equals negative 2/3 x plus 5. So what do we do here? So notice how we put the minus 2x over here with the 15. So we got this. And then we divided both sides by 3 or multiplied by 1/3. Same thing. And if you do that, then what happens is you're going to divide this by 1/3 or 3 and then divide this by 3. And so this divided by 3 gives you negative 2/3. This divided by 3 gives you 5, and you're done. Okay. Okay, next example. Solving equations of the form ax plus b equals c using the general formula. So now this is a general formula. So be careful here. This only works when you have equations of this form. Ax plus b equals c. Okay, so it says solve this formula using the formula developed, and it checked your solution in the original equation. So we're going to back substitute and check. Okay, so notice what happens here. For this equation, this is what we're going to use. The formula is this. So anytime you have this type of form, your x is going to be c minus b divided by a. So all you have to do is figure out what your a, b, and c are. So a is 6, b is -1, and c is -25. And then all you have to do is plug into this formula. Or just remember, just solve using the properties. You don't have to memorize this formula because all you have to do is just remember how to solve for x, and you'll get the exact same thing. Okay, and so once you plug and chug, you get x is equal to -4, and then what you want to do is go back to here and see if you get -25 when you plug in -4. Make sure that this side actually gives you -25. So here you get -4 times 6, which is -24. Then -1 gives you -25, and we're done. Okay, and there's the check. Okay, so always check your work, especially on homework problems. Okay, get in the habit of always making sure you check. Because it may come to a point where you go to check, you get an answer, and you go to check it, and you don't get the same thing. And if you don't get the same thing, then this cannot be a solution. Okay, so just because you get an answer here doesn't mean that it is a solution all of the time. Okay, so problem solving guide. So here are the general problem solving. Okay, here's what you want to do. 1. Gather and organize information. Read the problem several times, forming a mental picture as you read. Highlight key phrases. List given information, including any related formulas. Clearly identify what you're asked to find. Basically, I do this, and this is probably the most important step, because if you don't understand the problem, you're not going to get the right answer. And so what you've got to do is you got to make sure you read the problem carefully, make sure you understand what they're asking you, and then understand what information they're giving you. I always write down the information given to me in the problem. Any numbers that they give me, I want to know what those numbers are, and I want to write them down. Okay, any formulas, write them down. If not for any other reason than not wanting to have to go back and reread the problem and look for the information again. Okay, just save yourself some time. Then make the problem visual if you can. Now again, you may not always be able to do this, but draw a picture, draw it and label a diagram. create a table of values as appropriate. So different things will be more appropriate for different types of problems. Okay, some problems it's not going to be easy or practical to draw a picture. Okay, but if you can, definitely do it because a picture can definitely help you visualize and help you solve the problem. Okay, and this will help you see how different parts of the problem fit together. Then, after that, develop an equation model. Okay, so basically develop an equation to represent what's going on. So assign a variable to represent what you're asked to find. Okay, that's your unknown. And then build any related expressions referred to in the problem. Write the equation model based on the relationships given in the problem, and then carefully reread the problem to double check that your equation model is correct. Because I have done problems where I've come up with a model or I've come up with an equation and then went back to the problem, realized, oh, I did not build my model correctly. And then finally, use the model and the given information to solve the problem. So substitute the given values that you wrote down from the first step, then simplify and solve, and then state your answer again. Complete sentence with the units of measure that are indicated, but then also make sure you ask yourself and check that the answer is reasonable. Okay. A lots of time, especially with application time problems, students always make the mistake of never looking at their answer at the end and asking themselves, does this answer even make sense? If I'm trying to figure out the volume of a balloon, the volume of air in a balloon, or the volume of liquid in a bathtub that's being filled at a given time, and my answer comes out to be a negative answer, you're going to definitely want to ask yourself, does this make sense? Does it make sense to have a negative volume if you're talking about like volume of liquid or volume of a fluid or something? And the answer is no, of course not. So if you get a negative answer, then something's wrong. It can't be a solution, right? So there's that solution part again. If you solve an equation for t equal to time, and you get two possible answers, right? Two possible solutions for t, and one's negative and one's positive, then the negative answer can't be a solution because we can't have negative time, right? So we're only going to be interested in the positive values of t in that case. So again, so always ask yourselves, go back and double check and say, hey, does this make sense? Does it pass the gut check? Okay, in a manner of speaking. Okay, so example 7. So solving an application using the problem solving guide. So now here's what we have. We have the largest state in the United States, that's Alaska. It covers an area that is 230 square miles, more than 500 times that of the smallest state, Rhode Island. Okay, so let's read that again. What's going on here? That can be confusing, that part of the sentence. Okay, so the largest state, which is Alaska, covers an area that is 230 square miles, more than 500 times that of the smallest state, Rhode Island. Okay, so that means, so again, let's understand this. That means that if I take the area of Rhode Island, whatever that is, and I multiply that by 500, so I take 500 times the area of Rhode Island, that's what it's saying here, right? That's what this part of the sentence says. 500 times the area, so is that of, which means we're talking about area here, because that's what they're talking about, area over here. So it says 500 times that of the smallest state, Rhode Island. So if we take the area of Rhode Island, multiply it by 500, and then here it says Alaska's 230 square miles more than that. More than what? More than this here. So we're going to take whatever this value is, and we're going to add 230 miles, 230 square miles rather. Okay, so now that you have a picture of what's going on, I hope, now what do they say? Here's some more information that you're going to want to write down. It says if they have a combined area of this. Okay, so what does that mean? It means that if you take the area of Rhode Island plus the area of Alaska, they have to add up to this amount, right? Now, and here's the question. How many square miles does each state cover? That's the question. That's the unknown. So now, what we have to do is we have to figure out how to solve this given the information that we have. So now, let's go through these steps together. So, we know that the combined area is 616,460 square miles. We know that Alaska covers 230 more than 500 times the area of Rhode Island. That's what we just discussed. Okay? So this is we're gathering and organizing our information. Okay? Now, so here's a picture. So here's Alaska. Again, your picture does not have to be like this at all. But here's Alaska. Here's Rhode Island. And we're saying that Rhode Island is, we can fit 500 Rhode Islands in here by area. And then the green part. And then we've got this little piece of land left over that we have to add. Okay, so that's the kind of the visual. So what we do is we're going to let R represent the area of Rhode Island. Then, well, we're going to then let 500 times the area of Rhode Island plus 230 represent the area of Alaska. Okay? So then what we could do is we know that the area of Rhode Island plus the area of Alaska has to equal the total, which is up here, right? And so now all we have to do is plug in our values and our variables. So the area of Rhode Island is going to plus the area of Alaska, which is given by this formula, right, that we just derived. So this plus this has to equal this. Well, now what do we got? We got an equation that only has one variable. So now we can use the properties that we've been using to solve for the area of Rhode Island. So what do we got? Well, we solve and we get 501 times R is equal to 616,230. And then we divide both sides by 501 and we get R, the area of Rhode Island, is equal to 1,230 square miles. So now that's one piece of the answer, but we're not done because what do they want? They want the area of both. So the area of Rhode Island is this. Well, what is the area of Alaska then? Well, it has to be this amount, right? The total. We know that the total of them is this. So all we have to do is take this amount, 1230, subtract it from the total, and which is right here, right? This total here. And we got our answer. And so Alaska then is this amount, 615,230 square miles. And that's the answers. Okay. Okay, now what about this one? Now here we're going to involve geometry. So now what do we have? We have a sand at a cement factory is being dumped from a conveyor belt into a pile shaped like a right circular cone atop a right circular cylinder. Okay, if the diameter of the cylinder is 10 feet and the cone is twice as tall as the cylinder, how tall is the cylinder when the volume is 625 cubic feet? Okay, so there seems to be a lot here again. So we're going to rewrite that. We're going to reread this, and we're going to write down the key information. Okay, and here's where a visual is going to be very helpful. Sand at a cement factory is being dumped from a conveyor belt into a pile shaped like a right circular cone on top of a right circular cylinder. Okay, so we're dealing with two geometric shapes here, a cylinder and a cone. Okay, if the diameter of the cylinder is 10 feet, okay, so we got the diameter of the cylinder, and the cone is twice as tall as the cylinder. Okay, so now we've got a relationship between height, the height of the cone and the height of the cylinder. So now we know that both the diameter of the cylinder and the diameter of the base of the cone also has to be the same. Okay, so we've got that is 10 feet. Now the question is, how tall is the cylinder when the volume is 625 cubic feet? So here's what we're going to do. So again, we're going to go through the steps. So the first thing, we're going to write down the information, right? So we know that the diameter of the cylinder is 10 feet. The height of the cone is twice the height of the cylinder. And the volume is 625 cubic feet. Okay, and what do we want? We want to find out what is the height of the cylinder. So here it is. Okay, so here's the diagram. So here's our cone, and here's our cylinder. Okay, so we know the base of the cylinder, the diameter of the cylinder is 10 feet, which means that the diameter of the cone base of the cone is also 10 feet in diameter. We got the height of the cylinder, and we know that the height of the cone is twice the height of the cylinder, even though we don't know what those heights are. And that's fine. We're just trying to fill in the gaps here. Okay. Now, again, we're going to let h represent the height of the cylinder, and we're going to let 2h represent the height of the cone. And what do we know? We know that the volume of the cylinder plus the volume of the cone equals what? The total volume, which is 625 cubic feet. And so the volume of the cylinder, so here's where you need to know the formula of a cylinder. Well, the volume of a cylinder is base times height. You know, if you talk about dimensions, volume is base times height times width, or length times height times width. But when you're talking about a cylinder, well, the bottom and top of a cylinder are circles. So what's the area of a circle? So the area of a circle is pi r squared, and then that's the area here, and then we're going to multiply by the height, and that gives us volume. So the volume of a cylinder is pi r squared times h. And now the volume of a cone, okay, is 1/3 the volume of a cylinder. So the volume of a cone is going to be 1/3 times pi r squared times h. Okay, so those are two formulas you're going to want to know. Okay, so here it is. Okay, so now here's the cylinder. That's the volume of the cylinder. The volume of the cone, they make it into capital H, right? But what is the height of the cylinder? What is capital H? Well, that's 2 times h. Okay, so again, I would just put in 2 times h. So it's going to be this plus 2h here. And now what you do is you plug in the values of r. Well, do we know what r is? R is the radius, right? The radius of a circle, right? So r is half the diameter. And we know what the diameter is. It's 10. So that means the radius is half of that, which is 5. And so now we just plug in and we solve for h. Okay, so now here's where we go. So now look at this. So we simplify, right? So this is 25. And this is 25 times 2, which is 50. So 50 divided by 3 because we multiply by 1/3. So now it simplifies to this. Now what we're going to do is we're going to factor out the h or add, since these are like terms. So this is 25 pi plus 50 divided by 3 times pi, which gives us, if we get a common denominator, is 75 plus 50, which is 125. So we get 125 divided by 3 times pi h equals 625. And if you divide both sides by 125 divided by 3, then what you do is you get, and divide by pi as well, you get 15 divided by pi is the height, which is approximately 4.77 what? What are the units here? It's 4.77 feet. Okay, so that is the approximate height of what? The cylinder. Okay, so the cylinder is approximately 4 feet 9 inches tall, right? And how do we get the 9 inches? Because you're 0.77 or 77 hundredths of what? Of a foot. And so 77 hundredths of a foot is approximately 9 inches. Okay. But again, you could leave it like this. I'd accept 4.77 feet. Okay, so here's another one. Solving an application involving uniform motion. So it says, I live 260 miles from a popular mountain retreat. On my way there to do some mountain biking, my car had engine trouble, forcing me to bike the rest of the way. If I drove 2 hours longer than I biked and averaged 60 miles per hour driving and 10 miles per hour biking, how many hours did I spend pedaling to the resort? Okay, so again, we got to understand what's going on here. So he lives, or I live, 260 miles from this mountain retreat area. Okay, so I know the total distance, right? Now it says that I drove for 2 hours longer than I biked. So the amount of time that I biked, which I don't know, is t, let's say. Then the amount of time I drove is going to be 2 times that, right? Or excuse me, I'm sorry. I'm not rewritten. It's not going to be 2 times that. It's going to do 2 plus that. It's going to be that plus 2 because it says I drove 2 hours longer than I biked. So if it took me 3 hours to get the rest of the way there, then I drove 5 hours. Okay, does that make sense? So it means that however long I biked for, I biked 2 hours longer. So that's in addition. Okay, and it also tells me my average speed or velocity. So I averaged 60 miles per hour driving and 10 miles per hour biking. And then it says, how many hours did I spend pedaling to the resort? Okay, so now let's write out the information that they give us that we just went over. Okay, so the sum of the two distances, the distance that I traveled while biking and the distance that I traveled in the car, have to add up to what? The 260 miles. Okay. The rates are given too. Okay, so the rates of how fast I was going are given. And the driving time is 2 hours more than the biking time. Okay, So that's the important information. So now draw your diagram. So this is a great place to draw a diagram. So you draw a number line. And so here's my starting point. Here's the ending point. So I drove this far, let's say, and now the formula for distance is distance equals rate times time. So you're going to have to know that formula to solve this. And then here you biked this distance the rest of the way, and that distance is also equal, d equals rt. Okay. Now you could use small d and small rt and stuff like that, or capital to do that, or you can use d1 versus d2, r1 versus r2, and then t1 and t2. Okay, so it's up to you either way. But we know that the distances add up to the total, which is 260 miles. So let t represent the biking time, and then what's going to happen is capital T is going to equal the small t plus 2. Right? So I would just use small t for both of them. So this would actually be capital D is equal to capital R times the quantity small t plus 2. Okay? I would just put that in there. So now once we do that, that's pretty much what we're going to do is start to simplify. So capital D plus small t equals 260. That's going to be capital R times capital T times lowercase rt. And then you're going to substitute in and see what you get. So you get t plus 2, so 60. So the rate of the car is 60 miles per hour, and the rate of the bike is 10 miles per hour. And so now it's just solving for t. And once you solve for t, you get t equals 2. And this makes sense because time is going to be positive, so this makes sense. But make sure you take this and you substitute back into the original equation and make sure that that gives you a valid answer. Okay, so it says here, I rode my bike for 2 hours, which means that I drove for 4 hours. Okay, so that should make sense based on what we just discussed. Okay, so now let's go to the next one here. Okay, so here we go. Mixtures. This is another good one. This is a common problem that's given in college algebra classes or any algebra classes, mixture problems. So this one here, let's read what's going on here. It says, as a nasal decongestant, doctors sometimes prescribe saline solutions with a concentration between 6% and 20%. In the old days, pharmacists had to create different mixtures on their own, okay, but only needed to stock these concentrations, since any percentage in between could be obtained using a mixture, right? So you could have 6% and 20%. So you didn't have to have a whole wide range of concentrations because they knew that they could just dilute and do any mixture of the two to get the desired concentration that was prescribed. Okay, so now an order comes in for a 15% solution. How many milliliters of the 20% solution must be mixed with 10 milliliters of the 6% solution to obtain the desired 15% solution? Okay, so you're going to mix. What's going on here? They want a 15% solution. Okay. Now, the question is how many milliliters of the 20% solution must be mixed with 10 milliliters of the 6% solution to get a final result with a concentration of 15% solution. Okay, that's the question. So one, It's a volume question. We need to find what the volume is, right? So how much of the 20% solution do we need to add? Okay, and then our desired solution. So here's the thing. So we've got two things going on. We've got amounts that we're adding, right? 10 milliliters of one solution and the amount of the other solution, which we don't know. But we also have to include the concentration somehow. So here's what we got. So we only have 6% and 20% available. So we're going to take some of the 20% and we're going to mix it with the 6% solution, 10 milliliters of that. Why? Because we want to increase the concentration of the 6. So what we're going to do is we're going to take the 6% solution and we're going to keep adding the 20% solution little by little until we get an amount, whatever that amount turns out to be, where it becomes 15%. Okay. So this is the idea. There's our visual. Okay. And so we're going to keep adding until we get a 15% solution. So let X represent the amount of the 20% solution that we're adding. That's the unknown. That's what we need to solve, right? Then what we're going to do is 10 plus the X is going to represent the total amount of the 15% solution. Okay? So watch how this works. So the first quantity times its concentration. So we're going to take 10 milliliters of the 0.06% solution. So there's 0.06 percent, which means 0.06 parts of the drug per 100 milliliters or 100 parts of the solution. Okay, and so we get 0.6 when we take that product. Then plus X times this concentration. So we're saying, okay, 10 milliliters of this concentration plus X milliliters of this concentration, right, which gives us this, is going to equal what? Well, that's going to equal what? Well, X plus 10, so whatever that amount is, times what percentage? 15%, or 0.15. And so that should equal this. And so if we simplify it, we get this. So we get this plus this should equal this. Okay, and there is our equation. And all we're going to do is solve for X. And so when we solve for X, we get 18 milliliters. Okay, so in order to obtain a 15% solution, 18 milliliters of the 20% solution must be mixed with the 10 milliliter solution, 6% solution. So what does that mean? Well, we're going to end up with a final volume of 28 milliliters altogether. So our final solution, that's going to be 15%, which is going to be a 15% solution, will end up being 28 milliliters in volume. Okay, but the question is how much of the 20% solution must be added, and that answer is 18 milliliters. Okay, so I hope that made sense. Please go through these on your own, work them out on your own, make sure you know and understand what's going on. Okay, so that is the end of section 1.1. And so next time we will start linear inequalities in one variable. So this was linear equations. So now next time we're going to start talking about linear inequalities in one variable. So again, make sure you go back through these examples and you make sure you work them out on your own. Make sure you can get the correct answer on your own without looking at the solutions. Okay? And again, remember, when you come to class, ask questions. We're going to have lots of work to do. You're going to be working on your ALEKS, and there may be a quiz, so you want to work on your ALEKS now or during class. But the more you practice, the more you do your ALEKS, the better you're going to do in this class. Trust me. Keep doing the ALEKS and then ask me questions while we're in class. Until next time, enjoy, and I'll see you later. Bye-bye.